when you look at the map, there's some pretty interesting use cases in terms of using aluminum as a sovereign fuel, the ability to take locally sourced either primary or secondary aluminum and turn into hydrogen or as a fuel source. And furthermore, given that aluminum is a globally traded commodity, um, there are large stockpiles in certain areas. This one site in Vietnam, which has aluminum stockpile 2.5 miles wide by a mile deep and taller than a person, has as much energy using our technology as the entire Navy Red Hill fuel depot in the Pacific. Um, so, significantly large quantities of energy being stored in the form of aluminum around the world, now being accessible using our technology. So when you compare aluminum-based hydrogen to petroleum, there's some significant benefits. We see about half the volume and about 10% more weight. You can use any type of water along with some additives to produce both water and because it's a chemical reaction, we can do the reaction in a pressure vessel. The pressure vessel produces pressure, and that system can then pressurize reverse osmosis to do water purification. So, quick run through as to why the Army and SOCOM and Marines are interested in aluminum and hydrogen specifically as a potential logistics solution, not as a way to replace diesel, but as a way to augment or increase the number of options that they have. So now I'm going to get into the moonshine hydrogen technology we've been developing to meet those needs. So this video shows what's happening inside of our reactor. The aluminum has its oxide layer disrupted. That's why it doesn't look so shiny. And when it's exposed to water, aluminum oxidizes inside the water, rips the oxygen molecules off the H2O to produce aluminum hydroxide. That's the gray material there, and then allows hydrogen to go free. So all those bubbles there are hydrogen being produced with no electricity needed and any type of water. I used to have a Marine Corps colonel like to sabotage my demos by pouring hot coffee over the aluminum and start reacting, producing hydrogen using the water from the coffee. We've done significant work on this technology at MIT Lincoln Laboratory. We've got exclusive license to over 10 patents from MIT. We did systems like the hydrogen tactical refueling point, which enabled a handful of Marines to produce hydrogen for fueling UAVs and powering a combat operations center, producing power from balloon launch projects and a number of other projects while at MIT from 2018 to 2024 when we spun out the company. So Edge is now commercializing this technology using one fuel for many applications. The simplest thing you can do is to fill a balloon, feel a tight or altitude balloon, carry communication relay up in the air and provide over the horizon comms and sensing. You can run a fuel cell to produce electrical power. You can use the pressure that's produced by the chemical reaction to pressurize a water filter for water purification. And you can also self-pressurize up to 5,000 psi to refuel unmanned systems. So all the way from ambient pressure up to 5,000 psi are enabled by two reactors. This is our low pressure reactor, and we're also developing a higher pressure reactor for expeditionary applications. We group our work into three domains: air domain, which is aerostats and drones; ground domain, which is power generation and water purification; and maritime domain, where we basically take the ground power system, put it on a watercraft, and effectively build an ocean sipping watercraft, where the watercraft carries the aluminum and then can ingest seawater for the reaction. So the technology is as simple as pouring raw aluminum into the reactor, and then the reactor does all the mixing with water and thermal regulation in order to make the reaction work. So this is an early demo or early test we did, producing several hundred grams of hydrogen in about 15 minutes. We've done as fast as a kilogram in 5 minutes. That was a very sporty reaction.